Hi, let's understand business. In this session, we shall be discussing about the quality control charts for variables. Before we start discussing about quality control charts for variables, let us have a recount as to what basically is a quality control chart or what is a control chart, does a control chart look like. Basically, a control chart consists of certain points which represents the measurement of the quality characteristics which has to be controlled. These points are nothing else but samples taken from the actual population at various times and various moments. A central line is drawn at the characteristic mean. The mean is taken, of course, from whatever data which we have got. Based on that, we can take the mean, or if it has been specified, the standards has been specified, then that becomes the mean and that becomes the center line. Uh, again, there could be the upper and lower control limits. The control limits are those lines beyond which uh, the process is unlikely, or the process doesn't make any feasible sense, or which tells us that the process has gone out of control. We may also have the upper and lower warning limits. These are to indicate that there's an upcoming issue coming up with the process, or there's some problem coming up with the process. Regarding the quality control charts, there are basically two kinds of charts which we would be discussing. In this case, we will be discussing about the quality control charts for variables. These are used where the quality parameters to be controlled is measurable, or wherever we are to control something which is a quantitative attribute of a product. The basic types of quality control charts for variables are the quality control charts for a standard deviation chart, the mean chart, and the range chart. The other charts would be the quality control charts for attributes. These are used when the quantity or the quality is defined in terms of the product attributes which cannot be measured, or whenever we are to control certain qualitative parameters of a product, we take the help of the quality control charts for attributes. Basic type of charts in this are the fraction defective chart, the number defective chart, and the defects per unit chart. Of course, we will be discussing these aspects or the quality control charts for attribute in a separate video. Here we will be concentrating more on the quality control charts for variables. As mentioned in the previous slide, the quality control charts for variables are drawn for those parameters which can be measured. Whenever we are to control certain parameters for quality which can be measured, we use the quality control chart for variables. And here again, there could be two scenarios. Firstly, we can have a situation that even though we can measure the quality parameter, yet the standards of manufacture has not been specified or is not known. On the other hand, there could be a situation where the standards are known, or we know, of course, that if we have to make a chalk stick, maybe it has to be of 3 inches. So we know the standards, or we may not know the standards. So these could be the two scenarios. Where the standard of manufacture is not known, we take the help of the standard deviation chart or the sigma chart. On the other hand, where the standard of manufacturing is known, we use the mean chart and the range chart. So, the standard deviation chart or the sigma chart is drawn to control the quality of a parameter where the parameter, though can be measured, is measurable, yet the standards of manufacture has not been specified. That is, the quality parameter which we control through the standard deviation chart or the sigma chart, even though that parameter can be measured, it has a dimension or it is a quantifiable dimension that we are controlling. At the same time, the standards have yet not been set, or the standards are not known or not specified. When we draw the standard deviation chart, we need to calculate certain uh, parameters, certain points, which are first and foremost, we must know the size of the sample, the mean of the sample, and the standard deviation of the sample. So these are the three basic points with which we draw or we start to draw or construct the standard deviation chart. While constructing the standard deviation chart, what is important is the accuracy of the chart. We know from statistics that the larger the size of the sample, the more accurate would be the chart, or the sample would be more representative of the actual condition. So the population size or the sample, the population would be representative in a better way when the size of the sample is large. And to calculate the accuracy of the chart, we estimate it by the help of a term which we call as the standard errors of mean. What is standard errors of mean? Standard errors of mean is nothing else but it is the deviation of the actual mean of the population from the sample mean. It denotes the accuracy with which a sample is representative of the overall population. The standard deviation of mean is calculated by uh, dividing the standard deviation of the sample by the square root of the sample size. So as the sample size goes up or becomes higher, the standard error of mean would come down or would be smaller. So we would be more accurate and we would be more, our data would be more representative of the actual condition. Let us try and understand the concept of standard deviation chart or the sigma chart with the help of a simple question or problem. So the problem being a quality control sample of 100 items. The sample sizes 100 items was taken and the standard deviation of the same was estimated as 0.25 centimeter. See here, the standard deviation has been mentioned as in centimeter, which means whatever samples which we have taken, they can be measured and the measurement, the dimension is in centimeter. We have to estimate first and foremost the standard error of mean. We just discussed what it means, and we have to discuss and we have to draw the control chart for the sample. If the mean of the sample, whatever sample we have taken of 100 items, the mean is 10 centimeter. So on an average, the quantity which is to be controlled, its size is 10 centimeter and the standard deviation has been given as 0.25 centimeter. So first we move on to calculate the standard error of mean, which is, as we discussed in the previous slide, is the deviation of the actual mean of the population from the sample mean. It denotes the accuracy with which the sample is representative of the population. It is the standard deviation of the sample divided by the square root of the sample size, denoted by this formula. So we calculated that 0.25 centimeter is the standard deviation divided by under root of 100, 100 being the size of the sample. So which comes to 0.25 divided by 10. So we have an accuracy of 0.025 centimeter. What does this mean? What does this specify? What is its significance? This means that the mean of the sample which has come as 10 centimeter, the mean of the overall population or overall population from which the sample has been taken, that can vary from plus to minus, it would be 10 centimeter and plus or minus 0.025 centimeter. So whatever sample which we are taking or whatever calculation that we are doing, it is quite accurate or we are quite close to the actual situation. Now we come to the second part of the problem, which is we have to draw the standard deviation chart with the data where the sample mean has been provided as 10 centimeter and the standard deviation as 0.25 centimeter. This is a much simpler part of the problem where we draw the center line as 10 centimeter as has been provided, which is the sample mean. Since the standard deviation has been given as 0.25 centimeter, we know that the extreme limits would be plus and minus 3 times the standard deviation, or the upper control limit would be 10 centimeter plus 3 times the standard deviation, which is 10 centimeter plus 3 into 0.25 centimeters, which comes to 10.75 centimeter. So we have the upper control limit. Similarly, we know that the lower control limit would be 10 centimeter minus the 3 times standard deviation, which is 10 centimeter minus 0.75 centimeter, which comes to 9.25 centimeters. Once we have drawn the upper and the lower control limit, we may also be interested in drawing the warning limits. The warning limits, as we know, would be at plus and minus 2 sigma, or 2 times the standard deviation from the mean, which would be at 10.5 centimeter, the upper warning limit, and 9.5 centimeter, the lower warning limit. So this is how we draw the standard deviation chart. Now let us have a look at the other kind of quality control charts for variables. Other condition, that is where the standard of manufacture are known, or where we are to control the quality parameter of an attribute whose dimensions has been specified. In such a scenario, as mentioned earlier, we use the mean chart and the range chart. Usually both these charts are used together. To construct these charts, we need to take various samples of equal size from the population. We do not depend only on a single sample, rather we take many samples of equal size from the population at different instances. The mean and range of each of these samples are then evaluated. These means and ranges, so calculated, they form the basic data for the mean chart and the range chart. Basically, the mean chart is, or calling this chart as a mean chart is a misnomer. Actually, it is mentioned as the X bar bar chart. It is the mean of the means chart that we are to draw, and similarly we'll be drawing the mean of the range chart. So with the means and ranges so calculated, the mean chart or the X bar bar chart, it is used to measure the central tendency, and this particular chart shows the erratic or cyclic shifts in the process. It detects any kind of steady progress of change, like varying on the process, or those kind of things are specified or shown, indicated with the help of a mean chart or X bar bar chart. On the other hand, we have the range chart or the R bar chart, R bar being the average of the ranges. It controls the general variability of the process and is affected by the changes in the process variability. Whether there is a variation in process happening, it measures what is the amount of spread, or what is the range on which a particular output we are getting at different instances. To put these, since in these particular charts the dimensions are known, the means are known, or the dimension have already been specified, so we need to know the upper and the lower control limits. The upper and the lower control limits for the mean chart we use as the X bar bar, or the average of the means plus minus A2 R bar. Here A2 is a standard, R bar being the average of the ranges. Similarly, the upper and the lower control limits for the range chart, the lower control limit would be D3 R bar and the upper control limit would be D4 R bar. And as mentioned here, A2, D3 and D4, these are all standards, and these would be dependent on the size of the sample. We have taken various samples of equal size, so depending on whatever size of sample we have taken, these are already standard specified values which are used to calculate the limits of a mean chart and a range chart. Let us have a look at the mean chart and range chart again with the help of a small problem. So the problem which we would be discussing is that we have to draw the X bar bar chart, which is the mean chart, and the R bar chart, which is the range chart, for the data given when the value of A2 is 0.58, D3 is 0, D4 is 2.11 for a value of 5. And then we have been provided this table where there are 10 samples as mentioned, point number 1 to 10, and X bar and R of each of these samples have been specified. In this question, it is mentioned that A2, D3 and D4 values are for the value of 5. What do we mean by 5? Here 5 denotes that the whatever sample we have taken, whatever 10 samples as is been shown here in the chart, each sample is of size 5. So there would be 5 items within each sample. Of those 5 items, if we look at sample number 1, the mean or the average size is 7.0. The range is 2. That is, the difference between the highest and the lowest value of the sample is 2 for the first sample. Similarly, for the 10th sample, if you have a look, the mean is 4 and the range is 2. For the 6th sample, the mean is 11, the range is 4. So this is what the problem is. Now what we have to do, we have to draw the X bar bar chart and the R bar chart for the given data. So if you look at this data, since we have 10 samples and each sample is of size 5, so actually we are considering the overall sample size would become of 50. From the population we have taken 50 overall number of units, items at different point. At first instance we have taken 5, second again 5, again 5. Similarly by that time we have taken 50 items. So this is what the question is. First and foremost, what we have to do, we have to calculate the X bar bar. Since X bar for each of them has been mentioned, so what we will do, we'll add up all the X bar and divide it by the number of sample. So we have 7.0, 7.5, 8, 10, 9.5, 11, 11.5, 4.0, 3.54. We add all these and then we divide the complete with 10, which comes to 76 divided by 10, which is 7.60. Similarly, we have to calculate the R bar. So R bar would be the average of the ranges. So in a similar fashion, what we do, we add up all the ranges, 2 plus 3 plus 2 plus 2 plus 3 plus 4 plus 3 plus 2 plus 3 plus 2, and we divide everything by 10, which comes to 26 upon 10, which is 2.60. So it has been given, again we know that it has been given that A2 is 0.58, D3 is 0 and D4 is 2.11 for the value of 5. That is, the sample size is 5. Size of each of the sample is 5. As mentioned, the number of units in each sample for the mean and range is given, which is 5. So starting with the mean chart or the X bar bar chart, it has been calculated in the last slide that X bar bar was 7.60. So for the mean chart, we know that the center line would be 7.60. Then range was given as or calculated as 2.60, and we know that the upper control limit and the lower control limit are X bar bar plus and minus A2 R. So the upper control limit would be X bar bar, which is 7.60 plus 0.58. From the previous slide, A2 was 0.58 as mentioned, multiplied by 2.60, which comes to 7.60 plus 1.508, which is 8.108. So this becomes the upper control limit. Similarly, we calculate the lower control limit, which is 7.60 minus 0.58 into 2.60, which is 7.60 minus 1.508, which is 7.092, which becomes the lower control limit. So this is the basic chart that we. Now let us draw the range chart or the R bar chart. For the R bar chart, we know that the values of D3 and D4 was provided for the sample size of 5, where D3 was 0 and D4 was 2.11. Also, we had calculated the value of R bar, which had come as 2.60. So drawing the various lines First and foremost, we have the lower control limit. Lower control limit was D3 into R bar. Since D3 is 0, so it would be 0 into 2.60, which is 0. So the baseline would also coincide, or the lower control limit would coincide with the baseline. Coming to the center line as we know would be the R bar, which is 2.60. So we simply draw 2.60 as the center line. So we have the lower control limit and the center line. Coming to the upper control limit, we have D4 into R bar, which would be 2.11 into 2.60, which comes to 5.486. So we draw the upper control limit. So this is how we chalk out or draw the range chart or the R bar chart. Now that we have drawn the two charts, let us have a look at the mean chart and the range chart along with the basic data. So here we see that in the mean chart, if we are to plot the various points, we know that the first point, which is x bar, is coming as 7.0, would be coming somewhere here. Then the second point would be 7.5, next would be 8, and then it would be 10 beyond the upper control limits. So this is how we start plotting the data. Similarly, in the range chart, we have to draw, first is at 2, which would be around somewhere here, then 3, then again 2, then again 2, then 3, and so on. So the next point is that we start plotting all these data onto the two charts. In the previous slide, we had discussed about plotting the mean chart and the range chart over a diagram, rough diagram. Now let us have a look at the same plotted over a proper graph sheet. In this particular diagram, what you see here is that we have the lower control limit, which has been shown in purple line, the center line in red, and the upper control limit in green. And the various data which we had got from whatever we had been provided has been plotted in the form of these dots, what has been shown. So what does this particular diagram show, or what does it signify? In this diagram, we can see that while the first sample is just below the lower control limit, which is again not within the acceptable limit, but definitely yes, after the third sample, a lot of wearing out of the process is there. So there must have been a wearing out, and the process has gone beyond towards the upper control limit. The operator might have tried to adjust himself by bringing the system into the place when he had adjusted it here down below, but then again the wearing in has started and it is moving outside or beyond the range. So here we see that a lot of wearing out has happened within the process. Now coming to the other chart, which is the range chart. In the range chart, again similarly as per the earlier plot, we have the purple line, which is the lower control limit. The green line here in this particular case, however, is the center line, and the red line is the upper control limit. And once we have plotted the various ranges there, what has been provided, all of them are coming within the two control limits. So while the what does this particular thing show? This shows that while there has been a wearing out in the overall system, the variability within the process is still under control. So the process is under control, but the overall wearing out of the machine has happened, or of the tool has happened, and maybe it's time to change the tool or take corrective action, because the mean or the average, the overall sample is going way beyond the acceptable limit. I hope you could get an insight into the different kinds of quality control charts for variables through through this small video. For more comments or queries, please do write in at the given address. Thank you.